or how to make it better. But so I will start with discussing how to write the paper, because I think it's a very important topic for young scientists to focus on important aspects of what you are actually sending to the journal. But referring to the main question, what journal editors expect and what is searched upon, was to the large extent already discussed in the previous talk, because obviously journals look for the novel studies, for studies that are performed well using appropriate methodology. And I think this whole topic can be summarized by words of Sir Richard Peto, who was already discussed by Professor De Caterina in his talk, and who was my mentor when I was studying in Oxford. And he told me a sentence that I later found out was actually one of the first sentences of this meta-analysis that Raffaele has shown. And he said, always ask important questions and answer them only using reliable methods. And I think that refers and that answers this question. Yes, if you ask important question, novel question, and use appropriate methodology, as Dirk has described, very often confirmed using several methods, but including gold standard methods, then you will be able to publish your research. It's difficult to publish research. In one of the last slides, I have a picture of a duck, because I think that scientists has to be like a duck, where water doesn't stick. It's difficult to publish your story. It's difficult to read reviewer reports, which are very often critical. Sometimes we disagree with them, but you know, this is the process that is part of working as a scientist, and we have to appreciate that. Regarding the statistics and statistical expectations, journals, including cardiovascular research, have quite good descriptions of requirements in their instructions to authors, and we have actually concluded the preparation of a document that describes in detail, that was prepared by our statistical consultants, that describes in detail what actually cardiovascular research expects in relation to statistics, and this will be published in the next couple of months. But if we, I would like to start by discussing how, in general, to write the paper. And I think one of the books that I would recommend to you, it's an old book, because you can find a lot of books about how to write the paper, but this one is a little bit wider, and it actually helps not only to speak, but also to listen. Because I think that listening and understanding what people are seeking after in the topic that you are describing, in the topic that you are trying to convince reviewers to that it's an important finding, is a very important fact. So while writing, keep in mind that you have to listen, and this is a very good book. There is a 33, so 1/3 rule of research work, and I have first heard that from a scientist in Iowa, Mel Marcos and Don Heisted, who have always emphasized that 1/3 of our work is actually doing the studies, 1/3 is writing the paper. But note that we are not even close to the ending, and 1/3 is actually fighting the reviewers. Yeah, but it may sound funny, but this is a fact, you know. And many papers are actually somehow disappearing in this process, and people get discouraged. People think, well, maybe this is not strong enough. Maybe this is not good enough. And the second statement, also from Don Heisted, who was for a very long time an editor of ATVB, was it's easy to have things 90% done, but are they really done if they are only 90% done? So let's make sure. I think the first and the most important thing in writing a paper is understanding that you have to reach the 99%. The celebration you can skip, but you have to have the paper accepted. There are significant ways that changed already when I started my research work. We did the experiments, but actually the whole preparation of the paper was very complex, and it relied on secretaries, on people writing it, correcting it, on illustration departments that were very large in every university and made figures for us. And but now all of this is on us. We have to make figures, we have to make editing. Actually, if we have a good secretary, maybe she will proofread the manuscript. But in general, these roles have changed. And this is important because the whole process of preparing these data is critical because this is the way that reviewers and editors are going to look at your work. And one of the key things is don't be sloppy. And the problem is I am not very organized on my desk and so on, but when I start making figures, I am obsessive in moving things and adjusting, and my wife comes and says, this is unbelievable that you actually approach figures like this, yes? But it's thanks to the mentors who actually taught me this, that, you know, if you are sloppy in your figures, if you are sloppy in the way you've written the paper, if you have even, you know, minor mistakes, then people who, and this also reflects to writing grants, people look at this and they say, well, you know, if he or she doesn't pay attention to detail, then probably they didn't pay attention when they were doing the experiments. And that's why it sort of reflects on the whole work and has very important aspects. And that's why, you know, you should really pay attention to all the details, also formatting. You know, there are differences in the way when people just briefly look at the paper, impression that they get, you know, how you organize things. You can be a little bit chaotic, or you can be very well organized and make a very good impression. The second thing that facilitates the reviewers and editors reading your paper and not getting upset or discouraged at the early stage is not overusing abbreviations. Because every one of you working in very specific area, you use certain abbreviations all the time. But you know, here I can tell you the impact of TVR on Q was dramatic, with a 50% increase occurring during PVD induced by ACH. And you know, this is a citation from actual paper that was submitted, yes? And you read this and you think, my God, I don't know what this is. I mean, I can search for all of these and try to identify, you know, because these are obviously some of the things you can suspect, but some of the things are using sometimes even the wrong abbreviations. So do not use abbreviations because they don't really help you. They still count as word, and try to avoid as much as possible, because then it actually speaks to your reader and reviewer much better. And this feeds into the next rule, is simplicity. You need to write it in a simple way. Describe your idea, describe the novelty of it, make sure that you transfer this information, because this is, you know, this is how people, if people are not going to be excited by your story or your idea, then it will be difficult to convince them that it's within 15-20% of papers that should be accepted. Acceptance rate of majority of journals of circulation research is about 10%, of cardiovascular research is about 14% at the moment, which is horrible. Yes, it's very tough. And therefore you really need to ensure that all the little things are speaking very well to people. And so in general, in every form of writing, the secret to good writing is to strip every sentence to the cleanest components. So write your first page and then put it away, read it again and think about it. Can I remove any words? Do I need everything that was written there? Because, for example, when I write, unfortunately I write a lot of words. So I then go back to the text and remove them, actively remove them. Think, can I say this in a more appropriate and more direct way? Every word that serves no function, every long word that could be substituted with a short word, every passive construction. I think this is a problem of all the foreigners, that we overuse passive constructions in when writing in English, but we have to avoid overusing passive constructions. That leaves the reader unsure of who is doing what. These are 1,001 adolescents of that weakened strength of the sentence, and they usually occur ironically in proportion to education or rank. So it's sort of a criticism that is unfortunately true, even though it's old. Short sentences are received better than long sentences. This was said by Ernest Hemingway, and it's hard to argue with him about writing. Avoid several conjugations. Minimize statements that are very, very commonly used in papers submitted to us, at least. It has been shown, so-and-so demonstrated. It really doesn't. I mean, if you are saying, this is occurring, it has been shown. So adding these sentences or these things are not necessary, even though there is some culture of overusing them. Minimize superlatives. It's very easy for a reader or editor to consider that you've overstated your conclusions, because people do have tendency of trying to say, well, I'm going to say that this is the greatest discovery of the world. If it's not the greatest discovery, don't write that it is, because it only annoys the reviewer, and the reviewer is saying the conclusions are not justified by data. At the same time, don't try to downplay. If you have an important discovery, make sure you say this directly, but do not use unnecessary words. The example is, for example, drug X caused a striking increase in HDL. Better is drug X in increasing, so drug X increased HDL. And a person or a reviewer or reader can actually look at the data and can decide on their own if it's striking or not striking. Avoid things that break up sentences and make them not flow well. Write like you were speaking. Some people even record or dictate papers. This requires a little bit more sort of expertise, but especially for clinicians who dictate letters like we do in the UK, is a little bit easier, and people do that. Avoid things in parentheses, modifying phrases, because they disrupt reading of the sentence. You do not need to specifically state results. These are presented in figures, so there is no need to keep repeating and giving all the values that are already shown in figures. If something is very important and you want to emphasize it, then you can do this. And an example here is you can write a very long sentence. You see, intercellular glutathione levels were 15 plus minus 3 micromole and so on. Or you can say intercellular glutathione was decreased by hypoxia and increased by cysteine. This is different if you are doing an abstract. In an abstract, you can't present so many graphs and so much data. That's why in abstracts we often write data and write a little bit more details. But in the paper, when the figure is just available to the reviewer on the next page, I think this is making things more difficult. So the classical structure of the paper, unless obviously you are writing immediately a paper for Nature, it's slightly different, but in cardiovascular research and other journals, you write introduction. It shouldn't be too long. It shouldn't review all the literature. It should just give a reason for study. It should say why your study was designed, why it was conceived, and why this was a good idea. So you should make sure that the introduction is actually interesting for the reader and set up the rationale. And do not dwell on reviewing all the literature, because it's impossible that you review all the literature in an introduction. Methods is sort of a difficult part, because many journals, now it's slightly improving, but there was a period where journals were saying just to make half a page methods, yes? And maybe then more and more was transferred into supplementary materials. But make sure now that you use supplementary materials appropriately, because they do allow to describe all the details of methods. Be aware that methods section is the main section that editors look at the beginning at the paper. They look, is it a reasonable question? And then, are the methods used good quality? Are the methods used gold standard? And because if they are not, there is no point in looking at the results, because they will not lead to strong conclusions. When deciding on methods, refer to prior papers. If your group has used certain method, has optimized something, then it's good to refer to that. And but always ensure that you sort of give specifics of all the aspects. One of the specifics that very often is actually not focused on by many researchers in basic science is, for example, sex of mice. people say, we started C57 black 6 mice and so on, 15 with age 3 months and so on. And they don't say whether they were male or female. They assume everybody, there was time where doing experiments in male mice or in certain models of disease, male mice are more popular. But the truth is that now many journals are asking for mixed use of mixed sex of the mouse, and but definitely you need to say which gender was used and why. Use subsections, material, cell culture, animal studies, facilitate going through these methods as much as possible, and as I say, try to be very accurate and use protocols, describe protocols in appropriate ways, particularly in supplementary materials, in order to fit into the total wording of the paper. Please follow the instructions to authors, because I think people very often, it's difficult because sometimes you need to resubmit paper to 3-4 journals, but as much as you can try to fit to instructions to authors. If you don't, explain to the editor why. Because, you know, some people have very good paper, it was just rejected from circulation or circulation research, and you want to submit it to cardiovascular research. This is welcomed, and we can appreciate that, you know, you don't want to reformat it for 2 days in order to learn on the 3rd day that it will not be fully reviewed. So you can actually ask the editorial office to have a look at your paper, even though it doesn't comply fully with instructions. But if it's sent to the reviewers, it's better that the paper follows these instructions, especially in relation to length of the paper. You know, it's important that the messages are transferred in a short form. And from my daughter, I have actually learned very recently how long is the U.S. Constitution. Do you know how long is the U.S. Constitution? 4,500 words. So shorter than average scientific paper. And it's valid for quite many years. They did write a lot of amendments, so supplementary materials are thick, but I think it shows that it is possible to write in a short fashion. In cardiovascular research, we are not obsessed by word limits, and we are actually going to try to loosen allow for longer papers to be submitted from September. In results, make sure that the text flows, that the results remain interesting to the reader and are not just listings of numbers. Use transition between paragraphs and absolutely at this time avoid using data not shown. There is supplementary materials. If you have data, if you have observed something that is not significant and so on, you need to show it, because it needs to be available to people. More and more journals, and we are also considering and preparing to this, are requesting for full data to be actually submitted to be available to readers, or a part of the data be available in a form of actual databases. We still do not request that, although we did introduce, as Dirk has emphasized, a requirement for showing individual data points in all of the figures that are submitted, unless there is a genuine statistical justification, for example, in very large populations, to use box and whisker plots and so on. But do not say data not shown. Reviewers hate this. The reviewers get very upset. They usually say, well, this person is just showing some of the data, and it's simply not justified anymore. Show examples as well as mean data whenever possible. Many authors are just showing the mean data. They think, well, maybe in the thesis they include the examples, but I think that it is very important to show examples, and not only examples of Western blots, but examples of recordings from various physiological assessments and so on. Make figures so that the reader doesn't need to actually read the manuscript. The truth is that there is a paper that analyzed, there was numbers of scientists were given manuscripts, and they were filmed, and it was analyzed what did these scientists do with these manuscripts. And to be frank, majority of them read only figures. And so make sure that this is the most important part of your paper. And the way a person reads a figure, it can be shown like this. And you know, if you look at this, you really need to spend a long time to realize what's shown on this figure. But if you could add something like this, and then it makes it a little bit simpler. but still you need to actually look. The first one, the triangle is here and so on. You can do it this way, and then everything is clear immediately. Yeah. So make sure you make life easier for the reviewer, easier for the editor as well, because you know, every year European Heart Journal has about 4,000 papers submitted. We have about 1,600 papers submitted, and we have to go through them all. So so that means we really need to do a lot of reading, and that's why showing your main results in an accessible way is not only a way to get it published, but it's also a way to give it high impact. The same is for the histological studies. You can do it this way, and then somebody can appreciate there are some differences, but then has to, or you can do it this way, and then everything is clear, which what is which group and what conditions were done. Whenever possible, give examples. This is an example of our own study when we use electron spin resonance to identify nitric oxide production, and you can see very clearly the examples of recording. Simple, but it actually helps in reading to a reviewer. You can use this in many ways. Obviously, for Western blots, it's a classical way of showing the data. But for recordings from various different apparatus, it's also a key thing. Discussion is something that many authors seem not to be very fond of, because they're already tired writing everything. They've already done the big thing, and as I said, there is this sort of impression that most people don't read discussion, but actually some reviewers do. So I think if it's well written, it really tremendously adds to the manuscript. It puts the manuscript in the context of other studies. It compares it. It gives you an opportunity to explain why certain things were done the way they were done, where certain drawbacks or shortcomings of the study have to be there, because every study has a shortcoming, and editors, reviewers, and readers know that. So make sure that this is important. The statement from my mentor David Harrison is avoid unstructured rambling. Which indicates a very important point, which people often do not really follow. And this is, when you discuss something, don't keep discussing it in paragraph 1, 3, and 5. Discuss it all in paragraph 1, because this is when the reader is actually reading about this, and they don't want to be brought back to this topic later in an unstructured way. Also, structure your paragraphs in a way that classical writing is suggested. First sentence, what you will be talking about. Next 3, what is the content. And last sentence, summarized. And this is the way to, just a standard way of writing, but when we read many manuscripts, it seems that people do not really follow this rule. Major mistake is to make discussion too long, because then if the discussion is too long, it will very likely not be read. And also inclusion of unrelated issues, inclusion of some too much epidemiological data that, you know, if you are doing a basic science experiment, justify your question with epidemiology, but not necessarily discuss for 5 paragraphs all the epidemiological studies, because very likely and it's unlikely that epidemiologists will be reviewing it, and if he will, your description will probably not be sufficient. And the final thing, which typically maybe we don't need to say because it's obvious, but many people actually repeat results in discussion, so don't do that, and make sure you remove all the actual data and results. Figure legends should be quite descriptive, because as we said, we want to give the reader and the reviewer an opportunity to actually know what's in the manuscript without reading very detailed text. They want to go through the figures and know what is the main message. And that's why the first sentence should be like a title, then very brief description what's in the figure, and you don't state conclusions, you leave them in results, but give some important information that is essential for identification of understanding the figure. There are different ways of showing statistics. And this is very often sort of a personal preference of the author, and I personally prefer when p-values until we use them. I can appreciate that confidence intervals are a valuable way of presenting data, although I do think that it depends on number of data points, on the size of your population, on many factors, how important they are. But you can present stars, and then somebody has to look, oh, the star is here. Does the star mean a multivariate or repeated measures ANOVA, or mean something different? Or you can try to show directly in the slide. And then, be aware that every practically manuscript, at least in my case, practically every manuscript I wrote was always rejected. And there are some people that are more lucky maybe, but you just have to change the manuscript, rewrite, make as many improvements as possible, and submit to another journal. And don't take it personally, because 14-15% acceptance rates, this is low. Yes? So that means if your paper is rejected, it was in the 85% of papers submitted to that journal. And then, as I said, the last 30% is actually responding to reviewers, and I think it's a very important element. It's very important to try to actually address all the reviewer comments. And both editors and reviewers really do not like when authors are arguing too much and not providing data. If you can, provide data. If you cannot, explain to the editor and reviewer why you are not providing data. Do not say, well, we are not going to study mechanisms because there are so many mechanisms that can be involved in this. This is a quotation that is very common. There are so many mechanisms that we cannot investigate all these mechanisms. And we say, well, then do the RNA-seq and then draw some conclusions and propose mechanisms. I mean, this is not a justification that there is many options and you don't know which one to choose to justify why you are not addressing points of the reviewer. But try to sort of very systematically address everything, show as much data as possible, because this is what I think is important. Make sure that sometimes reviewers are making mistakes. If they make mistakes, if they make too many mistakes, you should write to the editor and say, well, in my opinion, we disagree with so many statements of this reviewer that we actually request that they are not reviewing this work anymore. And in majority of cases, unless it turns out that you are actually saying that the biggest expert in the field has, according to you, knows nothing about it, which has happened to us as well, then we will send it to that expert again. But in other cases, if the editors go through the responses and questions again, and can appreciate that if you are correct, then this reviewer will not be asked to review the paper. You will, unfortunately, an additional reviewer will be asked, which can lead to additional questions, but not necessarily. And especially if the answers are reasonable and strong. One of the things that is always, when you start doing revision, and usually it takes us several months to do experiments, it's very tempting to add additional things. And I think that it is not always a good idea. Keep it for another occasion, or maybe if they ask you again. But do not show new things, because the more new things you will show in response to reviewers, the more new questions you're going to get, because the reviewer can interpret your findings differently to you, and you may think, oh, this is a great result, and they may not think that. So show and answer only the questions. And then read the letter from editor. Editor very often specifies and says, gives a hint which reviewer comments are most important to publish the paper. And now, towards the end, very briefly, some comments about the cardiovascular research and key sort of priorities and things that we are looking for at the moment. The sort of main motto of the journal that was actually created with great help of Jeremy as well was actually scientific discovery driving clinical delivery. That doesn't mean that we are going to, or we want to become a clinical journal, because we are not, but we want to ensure that there is a translational value to the papers, and the context of questions that are asked can be interpreted in relation to basic mechanisms. Obviously, that does not indicate that if there is an important basic finding, we will force the author to come up with some strange explanations of clinical usefulness. But I think this aspect helps very much. The key elements that we are searching for are novelty, as emphasized by Dirk, sufficient mechanistic insight. We generally are not publishing, and we are not seeking for papers that have measured something in patients and are describing the comparison between two groups, unless a new molecule was discovered by some proteomic or other method and is suggested as a biomarker. Just simple comparisons between groups that lead to no mechanistic insight are not of interest for our journal. We are searching and asking the reviewers to assess if the paper is impactful, if it uses appropriate methodology, if it is reproducible, so if the data shown are based on n equals 3 or n equals 5 or are clearly described. And obviously, consulting with many statisticians, some statisticians say, in fact, there is nothing magical about 6. Why 6, not 7? Why 5, not 3? But I think that we need to ensure that there is sufficient reproducibility. So we actually seek for appropriate reproducibility and repeats, apart from certain experiments, like some of the single-cell RNA-seq experiments that can be done on a smaller number than 6, and it depends on specialist editor that is handling the paper, who usually has high knowledge of the topic. So these are the key sort of criteria. The areas that we are focusing on are the areas of current strength of the journal and areas that we would like to embark on and which we develop through publishing reviews and publishing spotlight issues in these additional areas. But obviously, we are interested in every innovative and novel discovery in cardiovascular research, and this is constantly evolving problem. Regarding the reproducibility crisis, and something that was quite widely discussed, every journal has to take some focus and points, and this was brought up by a number of pharmaceutical companies that have published a number of commentaries saying, well, all these scientists are paid millions from public money, and we are trying in our laboratories to reproduce these results, and we do not do very well with that. So this is a problem. It's a problem that is, I think, more complex than just a simple thought of fraudulent data or problems with reporting. But it is an issue that, as scientists, we have to remember, and journals are very actively seeking how to ensure reproducibility and the fact that the data can actually be shown. The good example is, and very well-known example, is the Bayer study that examines 67 target validation projects in oncology, women's health, and cardiovascular medicine, and they were only reproduced in 14 cases. Yes, so in their laboratories. Obviously, the problem is that it's very often a problem of best journals, because when a pharmaceutical company gets on a molecule, they are not usually picking molecules from journals that are not very respected and highly recognized. But you can see that the discrepancy or statistical errors in general are actually the higher impact factor journals. It's always a question. I have thought about this a lot, because I can't believe that people who submit paper to Nature are actually wrong from the very beginning. But probably the problem is that they are asked for so many things, and they are doing so many things in parallel, that then they agree to do n equals 2 or 3 on a smaller numbers, and then it simply becomes statistically not sustainable. That's my interpretation of this, but obviously this may be the other problem that we are facing, and we are requesting this more and more, is to ensure that basic science reporting includes information about randomization and blinding of observers. I think it is essential that all the experiments that are done in basic science are blinded and are randomized. And this is something that we have not been thinking about 10 years ago, and I think might have been one of the reasons for the reproducibility crisis. Obviously, it does not imply that people are very vicious and knowing which group they are cheating and so on. No, it's this sort of I would attribute to less sort of vicious bias, where a researcher is thinking, oh well, this is this mouse is getting this medication, so it should develop heart failure, but it's running, it's very healthy. So I think something is wrong with my experiment. Yes, I think this is not a good approach, and we need to do blinding. And interestingly, when we look at journals, the journals like cardiovascular research are actually quite good in reporting these aspects. And the lower journals are not as sort of good, and the higher the journal become, they have less maybe space to report this, or less pressure on the authors. To ensure the experimental quality, we check the following aspects. The list is longer, but already our editorial team in Glasgow is verifying these and providing these information to the associate editors, whether there was randomization, whether the conclusions are based on one readout, one experiment, whether there is all the results are presented, or whether some things are missing, whether all experiments have appropriate controls, whether reagents used are known and validated, and whether the statistical testing is appropriate. One aspect that was referred to here is technical versus biological replicates, and this is very important. We pay particular attention to this. We publish papers also about calcium signaling and various ion channels. And in this area of research, it's very common to isolate multiple cells and then patch clamp them and perform studies and report each cell as an individual value. And this is something that is, in our case, a lot of these papers are reviewed by David Eisner, and he has a very strong stance on this aspect, and we completely agree with him that we do need biological replicates in such studies, because any significance can be achieved when you study 300 cells in that kind of setting. The issue of image processing is important. Image processing is not completely banned, but it has to be done in an appropriate and reported in an appropriate way. Everything needs to be very clearly described, and since we took over the journal, we had maybe 3 cases of fraudulent image processing. The other ones were usually mistakes or some sort of unspecificities in what was left. Some strange things were appearing on our screens. Make sure that you are aware that journals are actually using software that detects many forms of image processing, and we see very often these images in a different way than you do. So ensure that everything that's done to the image is described, but most importantly, anything is done to the image has to be done to the whole image, because if it's not done to the whole image, it becomes fraudulent, and it's a very serious aspect. One thing that within Western blots that I always warn my fellows, because I have, while working in the United States, we've experienced this, fortunately was not sent to the journal, but a person was using stripping of antibodies. And then, we, on the lab meeting, we review the blots, and they are showing different NADPH oxidases, and each of them look identical. So they say, something is wrong here. And what turned out is that, they simply stripped the primary antibody incompletely, and then reprobed, and since then, for example, in my lab, we are not using stripping and reprobing as much as we can avoid it, especially if the bands are of a similar size, because it's just too dangerous. But avoid using any touch-up tool on any image that you are having, and avoid hiding parts of the image. If you think that your image contains things you don't want to show, get another image, or do the experiment properly, but do not try to present only parts of the information, because if we detect problems with image processing or some clear fraudulent problems, we are actually reporting these to ESC ethics committee, ESC Journals ethics committee, that then takes it on and makes its analysis and verdict. Karin Sipido has recently written a paper that is a little bit more optimistic about the reproducibility of results, and she focused on the fact that only some proportion is related to fraudulent and research misconduct. Some part is related to publishing misconduct, but also she emphasized that there is actually uncertainty of life and science, and this can be approached, or this can be remedied by use of different models to justify your statement. So if you are studying blood pressure, don't limit your studies only to Ange-2 hypertension. Study DOCA-SALT hypertension, study SHR, study various models, and ensure that your mechanism is observed in all of these. And we focus on statistics, so we have a statistical consultant that reviews majority of papers. Following their if we have the final revision, the paper goes to this consultant, and this is a basic scientist type statistician, so they are not going to ask you for some strange things. I remember in one of the circulation papers that I had published, the statistical consultant has written to us that they do not understand the statistics we are doing this. We need to put all the data in one table for all the figures, and then make a Bonferroni correction on number of comparisons that we are doing in the whole study. And we had 10 figures with 8 panels each. So we started explaining to them that every figure is a different question that we are asking. And when we are asking the second question, we haven't known the answer to the first question. We are waiting. This is a sequential process, but they were arguing with us a lot. Then they came back. We have addressed some of the questions. But then they came back to us and they said, well, the way it's written is also wrong. You should state hypothesis 0. So you should say hypothesis 0 for this experiment was. And then we actually wrote to the editor saying that this is this matter of style writing, and we have a different style, and we request that they appreciate that, and then they did. So so I think you can discuss if some of the things are unreasonable. But our statisticians, we have a statistician who is a genetic statistician and a sort of population statistician, but they are only reviewing studies linked to genetics, and the basic science is reviewed by a basic science focused statistician. And please, I think in about 4 weeks we will publish the statistical guidelines describing many possible aspects of publishing and analyzing basic science data. One thing that was not discussed too much is power calculations in basic science. I think that this is more and more requested by funding bodies, as probably Jeremy will relate to in the future. At least BHF is asking us, so please justify why you are using 6 mice, not 7. It is a difficult task because, what do we base? We haven't done the experiment yet with these measurements. So how do we do this? I have a colleague who is a very famous immunologist, and he says, this is no problem. We can always do a power calculation if we set appropriate values. But I think what is important is to be aware what question you are asking, what data you can use to make power calculation, because more and more awareness is present in relation to that, and can really help in designing the experiment. Randomization and blinding, please do not forget about this when designing and performing the experiment. One or two aspects that were already discussed here before is multi-center research and potential open science in relation to data sharing, access, but also potentially maybe placing protocols of your studies prior to publishing, performing a paper. There are suggestions that in line with clinicaltrials.gov or some repositories, basic science should start using such repositories. This is a difficult question because we change our scientific questions very often, and we would just need to probably hire a person to constantly modify our protocols, but it is something that is possible in the future and is, I think, coming. But the data sharing is becoming a standard, and more and more journals, and we are also preparing our platforms to be able to display and make all data that you are presenting fully available to all the people for their analysis. From the point of view of our journal, I would like to point to two aspects that we have recently introduced. One is scientific guidelines that we started publishing. We have recently published a paper on models of heart failure, and we are preparing subsequent studies. And the second thing is fast-track papers that were initially thought in a different way but have taken a completely different view. So fast-track papers at the moment are the papers that are particularly novel and that have, from the starting point, high probability of being rejected. So if you submit the paper like this, you have a higher chance of getting this paper rejected. But if it's not rejected, it will be considered much faster, and the reviewer and editor is asked to provide a following statement. Is this what the authors think is very novel and big discovery sufficient to publish this or not? If not, reject it. If yes, do not ask them to generate 3 knockout lines. Because one thing that we observed with discussion with various authors is that very often our reviewers are requesting large number of experiments. And this is correct, and it's hard for us as editors to say to them, well, we want to publish worse papers, so we don't want this. Yeah, we are not going to do that, and therefore, in the case of papers that are really describing novel observations, we really want to ask the reviewer to comment. Is this strong enough? And if it is, then provide minor comments. If it's not, then we will not consider it further, at least in this category. So our aim is to widen the scope, increase inflow of manuscripts, and we did indeed since last year increased a number of manuscripts that we received by about 20%, have more international editors and authors, and a lot of our papers come from the United States and China as well. And increased speed of manuscript handling. At the moment, our sort of time to first decision is not maybe as good as hypertension, because it's about 23 days, but I think it's reasonable and it's within a reasonable limit. People often say that if you were doing a study for 3 years, I mean, is it really essential that it's reviewed in 14 days? I think maybe not, but I think if it's reviewed for 45 days, then it's not good. So we really put a lot of effort to address this. Thank you very much, and with this I will.
Thank you. Thanks, Tom. Lots of food for thought there. Questions for Tom? One there.
I'm Mohammad Mustafa Ansari from Iran. And do you have any advice on writing systematic reviews? And how often do you accept systematic reviews in your journal?
So we are primarily basic and translational study journals. So we do not publish typically systematic reviews and meta-analysis. But what we are trying to actually encourage very significantly is to include systematic review type data in the review papers that are submitted to or published in the journal. We have also initiated a possibility that actually our editorial office can help with some of the meta-analysis or systematic review analysis if the authors are willing to work with us, because we think, and our analysis of citations show very clearly that papers using systematic review and meta-analysis type are much higher cited than classical reviews. So we are interested in this, but this is not the main type of paper that we are going to publish. If something is unique, if something is very strong and it's part of a wider description, then yes. In the last 2 years, we probably published 2 or 3, one on PCSK9, one on some mixed aspects of basic science and clinical research related to outcomes of myocardial infarction. But Outside of that, we have not really published too many of those.
Thank you.
Raffaella, and then behind him.
Thomas, I agree with all you said, but I want to add one element of reflection on when a paper is rejected. Very often when it's reviewed by a good journal, it has a number of suggestions for improvement. My suggestion for the young fellow would be do not rush resubmitting the paper immediately without taking advantage of this, because this is very valuable information that you can have for improving, an incredible opportunity to improve your manuscript.
I agree, and you have to be aware that very often we get a letter from a reviewer saying, I have already seen this manuscript and the authors haven't improved it. So the fact that, authors sometimes thinks, well, this manuscript was reviewed by Circulation and they made these comments. So now when I submit to cardiovascular research, probably they should be less demanding. And maybe we are slightly less demanding, but we still want to publish highest quality science. So I completely agree that the paper needs to be improved as much as possible. One thing that I advise is, many people then take 6 months to resubmit. And I think that this is typically, unless the reviewer indicates a really fatal flaw in your paper, and you can appreciate that, then you need to obviously repair that. But keeping it for prolonged periods of time, from experience, my personal experience, leads to very often publishing it 7 years later, and that's something I would like to advise to avoid. But address the comments, because it's very common. It's very, very likely it will go to very similar or the same reviewers.
And the other, this is an opinion, but I would like to be discussed. Too complex papers sometimes have a worse fate than streamlined, slim papers, because complexity adds exponentially the possibilities of finding problems and finding.
Yeah. I agree, and there are two types. There is a type of author that just decides to just bury the reviewers and authors with data. And indeed, we open this, and we have some editors that are quite careful and useful in their comment about that, and they can actually sift out through all the data that's available. Sometimes in some journals it works, but typically, as you are saying, Raffaele, I think it leads to a lot of questions from reviewers, because every figure creates potential a question, and I think the manuscript should be a story. It should tell a story, not tell everything that you have ever done. It needs to tell why it's novel, what's novel, and what is the discovery that you are describing. And then also, not only it will be maybe better accepted, but then people are going to really appreciate this paper. Yeah.
Okay. Question behind.
Yeah. Yes. Yeah. Exactly. Yeah, and then very often reviewers are asking other questions. Some people are saying, "Oh, this paper is incomplete. This paper is incomplete." If you have a feeling that it's incomplete, of course, do not submit it. But very often, what reviewers are asking is different to what you think they would be asking. So I think that it's important to have it assessed. Give it to your colleagues. Discuss it with other investigators. Make sure that when you present during posters, write down all the ideas and questions that people ask you before writing the paper, because these people are having a mindset of your reviewers. So they will be actually asking you these kind of questions.
Okay. Now.
I really liked your presentation, and I'm glad you mentioned this reproducibility crisis. So many of us know there's lots of predatory journals, and there's sometimes papers get published even in good journals which are actually bogus papers, or not good. So what do you think about the idea of scientific journals applying for funding as scientists do? So this way they can just, like when you publish paper, you pay for the journal. So what if the money for the journal will come from funding body? Some scientists will decide how much money allocate, and this journal, which can do anything what he wants, but this body will have money for that. And also more journals would allow open access, so it will boost science more. So just, yeah.
So I think there is now big debate about something called Plan S, that is suggesting that all the research needs to be made freely available. And while this sounds like a great idea, I think it's a difficult idea, because it, in fact, you know, the devil, as always, is in the detail. And I think that you know, I don't think that journals are actually responsible primarily for reproducibility crisis and changing of the way that authors pay or not pay for papers or for publication or for access is going to actually make data better and published better. Of course, some journals already are subsidized this way. In some countries, there are actually funds from governments to support journals, and they get a lump sum every year. I think what is particularly important is journals like European Heart Journal, Cardiovascular Research, all the ESC family journals or AHA family journals, and so on. Journals that are actually run or overseen by learned societies. And I think that this is something that is overseen by Plan S, is overseen by many people, because these journals have a different mission. The mission of ESC journals is linked to the mission of the ESC, and it's not just to make money. So I think that this is a solution, in my opinion, the linking or strengthening learned society aspect of publishing. And that's why, you know, there are some editors like Amrita Arwala from British Journal of Pharmacology who claims that she will never publish anything that she does in a journal that's not owned by Learned Society, which is a tough statement.
She already has, but never mind.
Huh?
Very quick,
Very
Gemma.
quick one. Could you comment on the title? Should it be short, long? Should it invite to read it, or should it contain some keywords?
Yeah. I think that the title needs to just not overstate, but state very directly the main finding of the paper. If it's too long, it's not going to be interesting to the reader. It's hard to give very exact, but do not use abbreviations in the title, and make it not extremely long, because it's not supposed to be descriptive. It's supposed to inform the reader what is the main message of the paper, and I think these titles work best. Some journals, including ours, we offer help to the authors if we have a sort of medical writer team associated with us that can actually suggest to the authors changes to the title, but these are not absolute requirements. For example, from my experience with, for example, New England Journal, they make very often very strong suggestions to changes of the text in order to make it very bold and strong. Yeah.
Okay, I think we have to leave it there.
Thank you
very much.